Hello everyone. Let's look at 8D permutations. Before we introduce the permutations, let's review the product principle. Let's look at the first review question. How many 7-letter permutations can be formed using the letters of the word compute? We have already applied the term permutation here, but you can ignore the word permutation. You can just ask yourself how many 7-letter possibilities can be formed using the letters of the word compute. Based on the product counting principle, we can draw 7 lines to represent 7 steps. Step 1. We do have 7 different letters from this word compute. So the first letter or the first step in this possibility, we can have 7 choices. The second step, which means I need to fill up the second letter in this possibility, I can have 6 options. Step 3, I still have 5 letters to choose. Step 4, I still have 4 letters to choose. Then 3 letters to choose, 2 options to choose. The last one, I only have 1 letter left. Finish this task in steps. Therefore, the product principle can be applied. I multiply all those values. And based on 8C, we also know that we can rewrite this multiplication sequence as 7 factorial. 7 factorial, if you use the graphing calculator to find this value, the numeric value for 7 factorial is 5040. Let's look at the second question. How many 3-letter permutations can be formed using the letters of the word compute? They are similar questions. The only difference between these two questions is in the first question, I use all 7 letters. But in the second one, I only need to form 3-letter possibilities by using those 7 letters. You can draw 3 lines or 3 boxes to show 3 steps. Step 1, find the letter to fill up the first box, which is the first step. I have 7 letters in total, so the first letter I should have 7 choices. After I use 1 letter in the first box, I still have another 6 letters to choose. So the second step, which is the second box, there are 6 different ways for me to choose. Likewise, the last box, which is the third step, I can have 5 letters to choose. I use the steps to finish the task. Therefore, I multiply the number of ways in each step up. 7 times 6 times 5 is 210. Based on 8C, we also can rewrite this multiplication expression as 7 factorial divided by 4 factorial. We have a new notation, 7p3, for this question. So what is 7p3? 7p3, on the graphing calculator, we can use math, the same section probability. It's called NPR. So N is the number in front of P. R is the number after the letter P. So I need to put N value in. Let's put a 7 in, then go to Math, Probability section, Function 2, and put the R value in. We can find 7p3 is the same as 210. So this is a notation for 7 times 6 times 5. It's also the same as 7 factorial over 4 factorial equal to 210. What does this notation mean? So right now, let's introduce the concept of a permutation. What is a permutation? An ordered arrangement of distinct objects is called a permutation. This is the definition for a permutation. The number of permutations of n distinct objects. So you want to use n distinct objects and arrange them in order. How many different ways are there? We should have n times n minus 1 times n minus 2 times n minus 3 all the way down to 3, 2, 1. Based on the notation of factorial, we also know that this one is the same as n factorial. N factorial means I have n distinct objects. I line all those objects up in orders. How many ways are there? If I have n distinct objects, but I'm not lining all n objects up in orders. For example, the number of permutations of n distinct objects taken r at a time. How many permutations are there? The number of the permutations is npr. This time, or we can say this notation means I have n different objects, but I only take all objects out to line them up. What is npr? Based on this particular notation 7p3, we can see this one is 7 factorial divided by 4 factorial. 7 is 4n. 4 comes from 7 minus 3. Therefore, we can use the inductive reasoning to derive this formula npr equals n factorial divided by n minus r factorial. Based on the factorial knowledge, I can change this one to n times n minus 1 times n minus 2 times all the way to 3, 2, 1. But before that, I should have n minus r plus 1. Then n minus r in the multiplication. And look at the denominator, n minus r. Factorial means n minus r times n minus r minus 1 times n minus r minus 2 all the way down to 3, 2, 1. So that means for starting from n minus 1 all the way to 3, 2, 1 can be cancelled out with the entire denominator. Therefore, npr also can be equal to n times n minus 1 times n minus 2 all the way to n minus r plus 1. Let's look at how can we apply this notation in real-life problems. Let's look at the first example. A chess association runs a tournament with 18 teams. In how many different ways could the top 10 positions be filled on the competition ladder? So that means we need to have the top 10s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I want to have the top 10 possessions to be filled, I need 10 steps to finish the task based on the product counting principle. The first step, I need to find the first team to stay on the top. How many different ways are there to have one team to stay on the top? There are 18 teams. Therefore, there are 18 different ways. Once one team stays on the top, how many ways are there to fill up the second place. We still have 17 teams left. The same idea can be applied in step 3. 16 ways to fill up the third place. 15 ways for the fourth place. 14 ways, then 13, then 12, then 11, then 10, then 9. Since we finished the task in steps until all 10 teams can be found for the top 10 positions, we multiply the numbers of ways in each step up. But this is a long multiplication sequence. If you write this sequence out, it looks just tedious in the communication. But if we apply the permutation definition, so we can say there are 18 teams, I need to take 10 teams out and line them up in orders. Therefore, I also can represent this multiplication sequence as 18p10. Based on the definition for this notation, 18p10 equals 18 factorial divided by 18 minus 10 factorial equals 18 factorial divided by 8 factorial. All those three expressions are representing the same numeric value. If you want to find the numeric value, you can use this one on the graphing calculator. So let's find 18 P10 and put a 10 in. So it's 1.587890304 times 10 to the power of 11. If you use any of these two factorial notations, okay, any one of them, you also can find the same result. So let's work on 18 factorial divided by 8 factorial. Are we getting the same answer? Okay. Since it's a large answer, you don't have to put down the answer in the scientific notation. You can keep the answer as 18p10 or 18 factorial divided by 18 minus 10 factorial or 18 factorial over 8 factorial as the final result. Let's look at an example 2. The alphabet blocks A, B, C, D, E are placed in a row in front of you. How many different permutations could you have? How many different ways, how many different possibilities could you have? You have 5 objects. You want to take all those 5 objects to line them up. So we can say 5p5 or 5 factorial. Both of them are equal to 120. So right now we can use the permutation notation to write out the answer in one step. Instead of drawing 5 lines and fill up each line one by steps, and then apply the product counting principle to multiply the numbers of the ways in each step. Let's look at B. How many permutations end in C? This is a restriction in the permutations. We do have permutations with restrictions. In this case, using the lines to help you visualize the problem is a good way. In 5 steps, the last one has to end in C, which means I only need to have A, B, D, E, those 4 letters to fill up the first 4 lines, the first 4 steps. How many different ways are there? You can do 4 times 3 times 2 times 1, but if you understand the permutation notation, you can write on 4p4 equals 4 factorial instead of 4 times 3 times 2 times 1. 4 factorial 4p4 equals 24 different ways, 24 permutations ending in C. So let's look at C. We have a little bit more restrictions. So this time, for those A, B, C, D, E letters, we want to have the second place with A. We can fill up other letters except A and B for the third line. Then B has to be placed in the fourth place. Then anyone can go into this one. So A has to be here, B has to be here. How many letters are there still left? We have C, D, E. And the C, D, E can go into this one, or this one, or this one. So you can do 3 times 2 times 1, or you can just say, I have 3 different objects, and take all those 3 out to fill up in these 3 lines. It's 3p3, 3 factorial equals 6 different permutations to have this form, something A, then something B, then something again at the end. Let's look at D. How many permutations begin and end with a vowel? Among A, B, C, D letters, the vowels are A and E. So the first line has to be filled in with A. Then the middle 3 lines can be any letters except the vowels. So the E has to be here. But the problem is for A and E, you also can have maybe E at the beginning, A at the end. So anyways, the beginning, the end have to have A or E. So how many different ways are there to fill up the first line and the fifth line? The first line, you have 2 options. Once you determine the first line, for example, you fill up with A. The last line, which is the fifth line, there is only one way, which is E. But for the middle 3 lines, I still have B, C, D, those 3 letters left. So I can have B, D, C, B, C, D, C, D, B, anyways, 3 letters to form different permutations. How many ways are there? How many permutations are there? We can times 3p3. 3p3 is also the same as 3 factorial. So you also can say 2 times 1 times 3 factorial. Some of you guys want to ask, how did you know you have to do those ones with times? So right now you can analyze the questions in steps by this way. Step 1. Use A or E to fill up the first line, the first place. Step 2. Use the remaining vowel to fill up the fifth line, the fifth place. Then step 3. Use B, C, D to fill up the middle 3 lines. Since I finished the task in 3 steps, therefore, I multiply the number of ways in each step up. There are 2 different ways to fill up the first step. There are only 1 way to finish the second step. There are 3p3 ways to work on the third step. If you find the numerical value for this answer, 2 times 1 is 2, 3 factorial is 6. There are 12 different permutations to begin and end with a vowel. Let's look at the last example. There are 8 different books arranged in a row on a shelf. In how many ways, in how many permutations can 3 of the books A, B, and C be together? This is a very classic permutation. Some things, some objects have to be placed together. So like this example, A, B, C, those 3 books have to be arranged together. This question is also called group permutation problem. A, B, C, they have to form a small group themselves. So what I will do in step 1, take these 3 books as one book. I put on ABC as one book. Or I can use a string to wrap them up. Just make sure those 3 books should be considered as one book with another 5 books. Then step 2. The reason why I say steps in my analysis is, if you just take ABC as one book, the task is not done yet. I do have other things to do to finish the task. What is the entire task? I need to arrange all 8 different books with ABC together. So then I will have ABC as one book. Then I still have D, E, F, G, H, another 5 books. So there are 6 books to be arranged in a row. So that means I still have 6 books to form different orders, to form permutations. How many different ways are there? So in step 2, 6 books to form permutations. There are 6 factorial ways, or 6p6. How many different ways are there for ABC to form a small group? In the small group, you can place ABC as ABC or BCA or ACB. Anyways, those 3 books can form different permutations, can form different orders. 3 books means I have 3 factorial permutations, 3 factorial different orders. Or you can do 3p3. In order to finish the entire task with 8 books to be arranged in a row on a shelf, I finished this entire task in 2 steps. Based on the multiplication counting principle, I need to multiply the number of ways in each step up. So it's 3 factorial times 6 factorial ways. Therefore, the total number of the permutations of those 8 books arranged in a row on a shelf with ABC being together is 4,320 permutations. This is the end of this lesson.